Okay, this is the third part in the linear recap. The second part, we asked what is linear. We defined it as the only thing as y equals to mx plus b. M is slope, rise over run, and then you have the y-intercept, which is here at the y-axis. There are other forms of the linear that we're just going to talk about. The two that is kind of loosely related is what we call standard. Standard looks like this. Ax plus by equals to c. The reason why this happens is because sometimes x and y comes together in that form. This could be in a word problem. And then the second one is what we call point slope. So we're going to write point slope. Point slope kind of uses the words. So here we're going to start off with y. And we're going to put minus b equals mx minus a. And this is the point slope formula. You have your slope, which is still m, but the only new thing is this, ab, because you have the point ab. I'm going to write that, a comma b. So this is all the critical parts about linear functions. Now, occasionally, there might be cases where we do have more than one linear equation. So on the back side of this recap that I hope you're writing, you're going to write system of linear equations. And so what is this? This one is when two equations happen. So when, for example, there could be a case where there's two lines like this, and there could be scenarios as to what we're talking about. We're going to draw the different scenarios that these lines could happen to be. So we're going to draw the three solutions. Let's draw the first one. The first one is if they don't have any solution. And solution means that the lines are touching. And so we're going to just try to draw that out. So we're going to draw it here in this box. Imagine if I had this graph. Here's y, here's x. The first scenario is where you have this line in red. That's your first line. And your second line is going to be drawn the same way. And notice, are they going to touch? The answer to that is no. What is this formula called? We're going to attach it to a box, and we're going to call it parallel. So I'm going to write the word parallel here. And the word parallel, sorry, I forgot to include the definition, means that they have the same slope. So I'm going to put that in a box. Parallel means same slope. Another way that we can think of it is that there's no solution. So I'm going to make another box and say that there is no solution. So same slope means no solution. Okay, then we have to think about two things, two other scenarios. The second one is going to be where they have the lines connecting. So here's what I mean by that. Imagine if I had, again, the XY graph, just like this. Imagine there was just one line, like going like this, and then the same line in yellow, probably just overlapping. So notice it's going to be overlapping, just like this. What do we call that? There's no proper name to this. We just, instead of it calling it parallel or anything like that, we just call it that there's all solutions. So why is it all solutions? It's because, and I'm going to put this in another box, that these are the exact same lines. So notice they kind of have this relation. Parallel means that they have the same slope, while this, having all solutions, has the exact same lines. Well, that leads us to do one more thing, finding the last scenario. And the last scenario is probably the more recognizable one, where you do have this graph like this, and then you're going to draw two lines. So here's x, here's y. I'm going to draw the first one in red for the first line, and the second line is going to be in yellow, and it's going to go across like this. Now, you might realize that there is a solution. A solution means, are they touching? And the answer is, yeah, they're touching right here. They only touched once. And so we're going to put this in a box where we're going to say it is one solution. Now, how do we sometimes find the solution? There are only two ways to do that. The two ways are this, and I'm going to make them both into different branches, and then we'll be done for this video. The first one is what we call substitution. So I'm going to make a box and say that this is substitution. The second one is going to be what we called elimination, and this is what we did more so near quarter 2. What is substitution? I'm going to draw it in this box. Substitution is when it looks like this. You have, you're going to have y equals to something, y equals to something like x plus 1 and x minus 2. It becomes this. X plus 1 equals x minus 2. And we're going to put that in a whole box. So that's what substitution is. In order for you to solve it, you're just going to mash them together. There's no more y, it's only x's. That's the idea of substitution. Then you have elimination. How does elimination work? As I kind of shorten this line, elimination works in a different way from substitution. The way that we do it is, let me just connect the line. They're both going to be in standard form this time. So I'm going to say 2x plus y equals to 3, x minus y equals to 2. The way that elimination works is that you cross off the y's and you put a big plus next to the x's. The reason why we do that is because we want to eliminate a variable. In that case, we eliminate y. There'll be different problems that we'll go through in order for us to explain these two ideas, where it's a linear function like this, the basic stuff, and the system of linear equations, which looks like these, all these three. But that's essentially the whole recap of what I wanted to explain.